Hello, everyone. We are back again to our math journey. And in this journey, we want to make math as, simple as possible. If you haven't joined our channel, which is Tutoring Made Easy, please do us a favor by subscribing, liking this video, and sharing to friends and family and people around you as well. We will want to continue from where we left off the other time. We are currently on Demorgan's laws, and then this is the second part of that particular topic, Demorgan's laws. If you could remember, I just want to take our minds back to the first law. There are two laws, actually. There are two laws, and the first one is what we did the other time. We said that if you have A union B, right, and you take the complement, we take the complement of the entire A union B, we said that the result is going to be A complement, the complement of A and or intersection B complement. I normally pronounce this and usually that's what I do so that I can be able to remember if I have to apply it to something. So we said that the first law says that if you have A union B, all complement, it gives you A complement and B complement, or A complement intersection B complement. And we went through the steps in proving this law. If you haven't seen that video, please do me a favor and you can look for that video, the Morgan's Law 1. The Morgan's Law 1. All right, today we are going to look at the second law, which says that if you have A intersection B, A and B, or intersection B, and you have all complement, then the complement of A intersection B, the law says that it should be equal to A complement union B complement. If you look at the trick here is the sign. When you have an intersection here with the entire complement, this the sign here changes. So intersection, union. Here, union, intersection. However, the same concepts are correct. The same concepts remains the same. You see this A complement, B complement, B complement, right here. What changes is the sign. So if you have A union B, if you take the entire complement, the sign in the middle should change to this, and you have your A complement and B complement, right? Then if you have A intersection B, and you have an entire complement, what changes is the sign in the middle. So you still have your A complement union B complement, like that. So that's basically what the two laws are. We have already gone through the first law and proven that. Today we'll focus on proving the second law. Proving the second law. So let's see how that goes. We're going to prove the second law. The second law. All right. I hope this is helping, has been helpful so far. I hope this has been helpful so far. All right. So the second law says, that if you have A intersection B, right? Okay. Oh, sorry. Let me write it down here. The second law says that if you have A intersection B, all complement, it is equal to A complement. I think A complement and and sorry, A complement union, yes, union B complement, like this. So let's begin to dive in. So we have our table here. Sorry, our Venn diagram here. This is a Venn diagram, and then we have our two sets in there. Why do we have two sets? Because we have set A and set B. Now remember, as you can see, sorry, this is A and B. We're looking for A intersection B, right? So if you have A intersection B, we know A intersection B is this region. This region is A intersection B, this region here. If you remember what we went through with Venn diagram, that'll be the intersection point. However, we are looking for the complement of that. And remember that with a complement, they are members or elements that are found in the universal set. They are in the universal set. The entire box here, the entire Venn diagram here, everything inside it is the universal set. So A intersection B complement are the members that are in the universal set. They are in the universal set, but they are not in the A intersection B region. So they are in the universal set, but not in A intersection B. So if that's the case, we are interested in this region. If that's the case, I think we're interested in that region, right? Because we want a complement of that. We don't want what is inside. What is at the region of A intersection B, we are not interested. We are trying to say that we are not interested in this region. This region is A intersection B. We are not interested. So what it means is that everything outside of that is what we are looking for, including outside the two circles. Because everything outside the two circles is not part of the green region. The green region is A intersection B. So now we know that our yellow region is our yellow region, our yellow region is A intersection. Our yellow region is A intersection B or complement. So I'm changing the colors because I'm saying that this region is A intersection B. So I'm going to write it as A intersection B in green color. And then the yellow region is our complement. The yellow region is our complement. So this side is our A intersection B or complement. So let me take off that and make this one also green. Yeah, A intersection B or complement. I hope we're okay so far. Now, the next Venn diagram we're going to draw is our A complement. Now we're going to have two circles again. Having two circles like this, and then we have our set A and set B, and we have our universal set. Now we are not interested in A because it is A complement. So anything outside of A, and we know that anything outside of A is here. We know that before I do that, we know that this region, this whole region here, this whole region here is A, is set A. So anything outside of this set A becomes our A complement. So let's go. So anything outside of that ring is our A complement. So like that. It has to be outside that ring, right? It has to be outside of it. So anything outside of it, you can see that, all right? So our A complement is the red region, right? Is the red region. So we can say that our white region is A, right? Our white region is A. Sorry. Our white region is A. So it's A white region, and then our complement is the red color. A complement is our red color. So this one here, this region here, and that region here, and this region all here, they give us what we call a complement. A complement. The entire red region is a complement. Now, what about B complement? What about B complement? So we are going to do that. Remember, we are currently on what? Union is A complement, union, and it's B complement. So we're going to draw another Venn diagram. We're going to show another Venn diagram for B complement, right? We're going to show another Venn diagram. Bear with me. We're going to draw another Venn diagram for B complement. I need more space for that. So we are having our union here. We're going to join them together. This is B complement. So we're still going to have two rings inside here. We have our two rings inside here. But you remember we need B complement. B complement is anything outside of this region. Anything outside of that region. So we can say this is set A and this set B. And then we can put the green, you know, we can rather use green for the other circle. So I'm going to use green for the other ring. Okay? And then Y for set A. So white is for set A. Alright? White is for set A. And then B is green. B is green. I hope you can see that. Now we are interested in B complement. B complement. What is B complement? Anything outside the region B. Anything outside the region what? B is what we are looking for. Anything outside the region B is what we are looking for. What we are looking for. So we are looking at this region here. Anything outside region B, which is the green region. It's outside the green region. That's what we are talking about. Anything should be outside of it. Yeah. It should be outside of it. Then we are talking about what? B complement. B complement. So we can see here that this region, that region, and this region all together gives us B. It gives us B complement. B complement. B complement is the one in purple. So we're going to first wipe off this. So B is the green region. B itself is a green region. And then the purple region represents the complement. So there we have it. Now, remember, the sign here is union. The sign there is union. Union means we are bringing them what? Together. Don't forget. Union means we are bringing it what? We are bringing it together. So to join them together is to join all the shaded region together. And if you look at it, we have, there is nothing here. If you look at it, there is nothing, there is nothing here. And then there's nothing in this middle here. However, here, something is shaded here, nothing is shaded here, right? But because we are joining, we need to bring this side in the shading. Whether it doesn't matter if something is here, because we are joining them together. We are not looking at intersection. Now, also here, something is shaded here, something is shaded outside here. If you also look here, something is shaded here, nothing is shaded here. However, we have to still bring that shaded portion together because we are not looking at intersection, but we are interested in the union. I hope you agree. So we are going to shade everything that has been shaded, whether it is in A complement or whether it is in B complement, and bring them together. So to do that, we are going to have another box, another Venn diagram, and then we're going to have our rings. Two rings. It is set A and B. and we have our universal set. Universal set, right? Now we can see that this outside region was shaded, right? How do I this side was shaded? How do I know that it's right here? It was shaded, so I'm gonna put that there. I can see that outside here was also shaded, so I'm gonna shade that. This side is also shaded, so everything outside will be shaded like that. And we can also be observant to realize that this side was shaded. This side too was shaded. How? Because it's here. Even though the side wasn't shaded. But we need to add it because we are doing a union. So we shade everything here. However, we're going to leave this region. We leave this region behind. The one in the middle. Here, we leave this region behind. We're not going to shade it because nothing was done here and nothing was done there as well. So there you have it. We have A intersection B. We have A is equal to A intersection B, right? Sorry. We have right. We have A intersection B, which is in the middle, and then the complement of that is the yellow region. The complement of that is a yellow region. So you can see that this diagram here is the same as this diagram there, and there you have it. All right, I hope this video was helpful. If you haven't subscribed to our channel, please do us a favor by please again subscribe, like, and share. I'll come to you another time. Take care. Bye.